Alright, the reason for this video is to show a 1D equation of motion problem in action. And it's pretty in-depth because we can't just solve it simply to find what we need. We'll actually have to use another problem in order to find some information in order to carry a specific value over to the area where we want to look at in order to solve for what's needed. This is coming from a cartoon clip from a TV show called Jonny Quest, which was back in the 60s. It was on TV, and even though it's a cartoon and kid-centered as far as the title character is Jonny Quest, the kid, it was pretty much adult-themed. Unlike in traditional cartoons for kids, you might think people could die, there was real danger. The world was sometimes teetering on the brink of, the madman winning out and destroying the world, or worse than that. If there's going to be anything worse than that. But nonetheless, there was the good guy, and that was Dr. Quest, Johnny's dad. He was a super scientist who seemed like he knew everything. And he could always save the day or figure out a way to save the day before the bad guys won. Some way or somehow, I don't know exactly why, his son and his friend Haji, Johnny was his son and his friend was Haji, always was tagging along. Sometimes it was accidental, other times they went with him, and I have no idea why the dad would allow his son and his friend to enter in these dangerous situations, but nonetheless he did. They did have a bodyguard, Race Bannon, who was the muscle of the group. He was there to protect Johnny and Haji, and specifically because Dr. Quest was so brilliant, we could not risk the fact that Johnny or Haji would be kidnapped by enemy agents in order to coerce Dr. Benton or Dr. Quest into selling out the United States. I have no idea where Dr. Quest's wife was at. She's either dead, I think they may have mentioned she was dead in episode 1, I forgot, or she just left him because the man lived a very, very dangerous life, and he seemed like he didn't care about anything except for his experiments. At least that was his primary goal. Johnny has a dog named Bandit who is always getting into trouble. It'd be better off if they just let Bandit perish in one of these episodes. But in this episode, he's going to be the cause of the problem. Bandit's going to run off, and he's going to cower in terror from this advancing invisible monster, which by this point has become invisible. They paint it. Don't ask me how that happened. The monster came about from a friend of Dr. Quest who was dabbling into making a energy source to power the world with free and abundant energy. The experiment goes awry, and it creates this living ball of energy which can dissolve or envelop and eat people. So therefore it has to be stopped. Dr. Quest is called in to do this, but before this all happens, Bandit is almost eaten by the monster, and in true dramatic fashion, Johnny goes to the aid of his dog, and he reaches the dog just as the invisible monster is reaching that spot. So we'd like to find out how far could he possibly start at the distance from Bandit in order to reach him at this critical, dramatic, almost close photo finish between himself and the monster. So enjoy Jonny Quest. We'll do the introductory first to give you a little idea what the cartoon's like, and then we'll show you the clip, and we will do the physics behind the invisible monster.
Stay back, stay.
Bandit! Bandit, come back here!
Johnny, I told you not to go out there.
I've got to, Race. Bandit's scared to death.
Johnny!
Johnny's got Bandit, Race, and here he comes.
Good boy.
So here's the problem, but I'm going to read it out loud just in case you can't read it. The problem starts with the invisible monster moving at a constant negative 3.5 meters per second to the left and located 30 meters to the right of Bandit. See figure below. Now, as a side note, since the monster is moving at a constant velocity to the left, that means its acceleration is 0. Right? So it's not stated there, but that's what that means. So you got to fill in that blank, even though it's not given directly, but it is. That's what's implied by constant speed or constant velocity. Back to the problem. At the same moment, Johnny lies an unknown distance X0 JQ for Jonny Quest's initial position. That lies to the left of Bandit. Johnny starts at rest, but accelerates at 1.5 meters per second squared towards the right. What is X0 JQ? Such that Johnny reaches Bandit at the same moment that the invisible monster has covered its 30 meters. All right, so we need to solve this problem here to find out how far good old Johnny can be from his dog Bandit at maximum, so that he can just barely get the Bandit in time, as depicted in the excellent cartoon clip from Jonny Quest, The Invisible Monster, which was the scariest thing I saw when I was a kid. And we like to know if the invisible monsters move at a constant rate of 3.5 meters per second to the left, as depicted in that drawing. And if he starts 30 meters away from Bandit, how fast or how far away does Johnny have to be or can be in order to reach his dog and save him in the nick of time to make the cartoon exciting? All right, so let's look at this. So in other words, I have this depicted in that previous graph, that drawing of the problem. Let's draw it up here. At x equals 0 is our dog, Bandit. Looks like a little pig there, but that's okay. And over here we have our invisible monster, which isn't so invisible anymore because they painted him. I don't understand how they can paint the monster, but it's a cartoon. I also don't understand how the monster can have one giant eye. It's made of energy, in case you don't know anything about Jonny Quest's The Invisible Monster. So the monster is starting over here. X initial for a monster equals 30 meters. And he is moving with a speed of negative 3.5 meters per second. And that negative means it's going to the left because positive X goes to the right. Remember, positive X goes to the right means all values positive are going to the right. So this is also positive V, positive V naughts, positive A, all goes to the right. And that's why this monster here has a negative, because he is moving towards the dog. And meanwhile over here, we have good old Johnny. Six-figure Johnny. There's some hair there. Running towards his dog. And we'd like to know how far JQ Jonny Quest can be and reach his dog at the same time. The invisible monster is doing his, slow but steady pace towards the dog. And the only thing we know about good old Johnny is that he's accelerating. And he's going to be accelerating to the right. So it's going to be positive 1.5 meters per second squared. And of course, I had to make up that number. just to get out there, actually, I don't know how fast if he can accelerate. Johnny's under a lot of stress to save his dog there, even though it'd be the best for the cartoon if the dog died. He's always getting into trouble. And actually, Johnny's pretty much a dead weight too, so just let him go too. And I think the cartoon adventure series would wrap up a lot faster than the 20 minutes of a lot of animation. All right, so we're actually going to need a couple tables for our motion here. Let's start with good old Johnny, and we'll see why. Just a second. There's X naught for Jonny Quest. There's X for Jonny Quest. He's finally going to wind up. V naught X for Jonny Quest. VX for Jonny Quest. A for Jonny Quest. And time for good old Jonny Quest. Now the time is how long he has to travel to go from his initial position to his final position, which will be where his dog Bandit will lie. So when he reaches this spot, he will cover this distance X Jonny Quest, which is where Bandit is. So his starts, he will end at 0. And that will also be where he's got his final velocities at as well. Now we don't know how fast it is because he is accelerating at 1.5 meters per second squared. And we assume that he starts from rest. He starts at rest, there we go. And he ends up traveling at some unknown speed. It's acceleration. We don't know how long he takes from travel as well. So that's also an unknown. And this is the unknown we actually want. We've got a couple zeros, which usually is pretty good, but we also have 3 question marks, which means it's pretty bad. We don't have enough information to solve for this. You can get out the equation of motion. You can find out there's no way to get X when you only know, there's no way to get X naught when you only know final position, your initial speed, and acceleration. So what are we to do? Well, you got to think about it. And usually what happens is in these problems is that there's some information that's going to be given by the other object, or maybe if when we, this is kind of what's going to happen when we do 2-dimensional motion, we start talking about X's and Y's, and sometimes some of the stuff in the Y is going to give us some information we can carry over to the X or vice versa in order to make it solvable for what we need. And the little monster, he's moving around too. He's going to have his own, he'll have his own little table here we need to fill. His own little scorecard, so to speak. So the monster starts at 30 meters. Where does the monster wind up? Next final. That's at 0. He wants to make it to the dog as well, or at least his position. He's on the cartoon. Almost gets there. V naught of the monster equals negative 3.5 meters per second when the clip starts. The monster's already in motion, and he's a slow moving monster, but he's constant. He just keeps on moving. So he will always have that speed or velocity, so to speak, going to the left at 3.5 meters per second because his acceleration is 0. Thank heavens, or he might get to the dog first. And we don't know how long he's in motion. Or do we? Because we have everything known here for the monster except for the time. So we can use any equation of motion that's got t in it and we'll be good to go. And now we have to think, well, when this problem begins, Johnny is racing towards the dog and he's got to have so much time to do it. The monster is going towards the dog. He has so much time to do that as well. So the times between these two are going to be the same, even though they're going to start at different positions. They'll cover different lengths of ground, most likely. They have the same time they're going to be working in. So there's our key. We're going to get the monster's time, how long it takes for him to travel 30 meters to get to the dog, dog's position, and that's how long Johnny has to work with if he wants to snatch the dog out just as the monster's reaching that position. So our key is to realize that the time that Jonny Quest has to work with is the time the monster is giving him. The monster gives him a long time, and Jonny Quest has got a long time to get there. He can start way to the left, but the less time the monster is going to take to get to the dog, the less time Johnny's going to have to do it. So I mean is if I find how long it takes the monster to go from 30 meters to 0, then I know how far away Johnny can be if he can move with starting at rest and accelerate with that rate. To get T of the monster will equal T of Jonny Quest. The equation you want, like I said, that has T in it for the monster's information. Let's pull this guy right here. Actually, let's do the first equation. Because the one I was about ready to write down. So let's say that the final for the monster. It's a good example here for this. Equals the initial of the monster plus A of the monster times T of the monster. And I think, hey, I know all the information. And even bonus, acceleration is 0. So I get negative 3 meters per second equals V of the monster final. And the initial is 3.5, negative 3.5 meters per second, the monster, plus 0 times T of the monster. This all goes away. I'm just left with 3.5 meters per second equals negative 3.5 meters per second. And that's great. That's what it should be. These numbers, that's the equation, still true, but it doesn't tell me anything about the time. So it's because sometimes you go information, sometimes those zeros actually work against us. So you just don't panic. You move on to the next equation. That was the one I started right there, and I thought it counts to show that first equation. And sometimes you pounce in there and don't panic if you get a bunch of zeros popping in there and you don't find anything new. Just go to the next equation. So we have the equation number 2. X monster equals X naught of the monster plus V naught of the monster times T of the monster plus 1/2 A of the monster, T of the monster squared. This is kind of a daunting equation because we panic, we got T's here twice. It could be a quadratic, and maybe we had to solve it from using a quadratic, and be lucky we got it. And there's always those other equations. There's one more equation down the road which might be able to can use to avoid it. But nonetheless, we don't have to worry about it because X of the monster equals 0. And A of the monster is also 0. So we're just left with the initial position of the monster, which is 30 meters, plus the initial velocity of the monster, which is negative 3.5 meters per second, times T of the monster, plus 0. So you solve this. The monster equals negative 3 meters over negative 3.5 meters per second. And T of the monster equals think about 8.57 seconds. So we can now run back. Say, aha, I found this. And hopefully you buy this explanation. Put that in right here. And now I only have two unknowns. I need the x, so I try to find an equation which has the x not in it, but not the final. And that's this equation up here, but for Johnny's case. Jonny Quest equals x naught of Jonny Quest. That's the one we want to find, this guy right here. Plus v naught of Jonny Quest times t of Jonny Quest, which is the monster's time, plus 1/2 acceleration of Jonny Quest times t of Jonny Quest squared. Now, good old Johnny starts at rest, and he ends up at 0. So we're left with x naught of Jonny Quest plus 1/2 a of Jonny Quest, give Jonny Quest squared. X naught of Jonny Quest, solving this equation for naught, just means moving this term over to the left side, moving it to the other side. And it's time to plug in some numbers here. So let's see, looking back at our table. Acceleration Jonny Quest is 1.5 meters per second squared. And the time Johnny has to work with is 8.57 if he wants to reach that spot where Bandit is at the exact moment the monster reaches it. And go, Johnny could start out at a maximum negative 55.1 meters to the left. All right, Johnny. It's negative, which we shouldn't be scared of because Bandit's at x equals 0, and Johnny's to the left of x equals 0, and that's the direction of negative x. So this is negative x direction or negative x number. So he starts over here at negative 55.1, and he starts at this spot right here at negative 55.1 and runs, starting at rest with this acceleration. He will reach this time, this spot right here in about, or it should be exception around 8.57 seconds, which is how long it will take the monster to reach right there to make the dramatic save that Jonny Quest does. So congratulations, Jonny Quest, you saved your dog to screw up another day. I've the cartoon Bandits. Like trouble. All right, that is an example of a 1D motion problem, an equation of motion. But it is two parts. You have to use some of the information for the monster in order to get a term which will go over for Johnny. And generally, the only thing that will move over is the time. Everything else is unique to the monster, unique to Johnny. But time is the only thing that usually can move back and forth, provided you're talking about the same span of time. And that's exactly what's happening here. So congratulations, Jonny Quest. You guys take it easy.